So, welcome to this morning's sessions on Maths FET tips and tricks for Sharp, the ELW 535 scientific calculator. And this is our plan. So I'm hoping it should take us between an hour, just over an hour to get through. And yeah, jump in if you have any questions or need help. For those of you who are watching on YouTube, you can pop your questions down below into the chat or the comment function, and I will answer them there. So just some great resources. I've added a link to Desmos, which I was recently introduced to. Desmos is really cool in the sense it's very similar to GeoGebra, but you can download it to your phone. So it's really nice for students who have access to phones or tablets in your classroom, and it doesn't require a lot of bandwidth for data, and it's also not a very big app, so it's and apparently quite intuitive. So it's a really nice one. Take a look at this. I'll try and remember to share the presentation with you at the end in the chat if you want to download it. Alternatively, I will also send the presentation on either Friday or Monday with a link to the YouTube clip for this workshop as well. So some quick basics. Obviously, your on button. A second function activates all of your orange functions, and we'll go through quite a few of them today. Your mode button gives you access to the 4 different modes that the calculator has, and I'll discuss those now. Your alpha button gives you access to your blue buttons, so we're talking about your statistics or your memory keys, which we'll use to solve the quadratic formula. Then, of course, your BS button is not what your kids write, but it means backspace. So in other words, to delete something. Change will change the way your answer looks. So between thirds, fractions, and decimal answers. And then, of course, your equals button is to find the answer. Okay, so from there we have 4 different modes: normal, stat, table, and drill. So normal does things like fractions, probability, trigonometry. It does time calculations. It's really quite a versatile part of the calculator. Then, of course, statistics or stat mode is for all of the statistics, and we'll cover both univariate and bivariate data or single data and linear regression. The table mode is particularly awesome, and we'll go through a couple of things there. I'll show you a very nice shortcut for teaching or finding the specific solution of a trigonometry equation. Now, I don't normally explain the drill function for grade 10, 11, and 12 FET, because I assume at this stage most students have got some form of mental maths capabilities. However, do take a look at it on your calculator, because the mental maths is actually really a critical skill. And so what the calculator does is it allows students to practice the mental maths on the calculator with getting instant feedback. So it asks a question, they have to answer it, the calculator marks it for them, and if they're right, they get a new question. If they're wrong, they get the same question again. So it's quite a nice system for practicing mental maths. Okay. So let me show you this very cool trick if you haven't seen it yet before. So what you can do on your calculator is it's actually basically to create a constant ratio. Okay, so for example, if you set a test out of 70 and you want to convert all of those marks into percentages out of 100, then at the top you would put 100, and that's where you're going to. At the bottom, you put where you are coming from, so that would be 70. And then you would say times, and you'd put in your first student's mark. So the first student got 40 out of 70. And equals, and we can change that to see that we get 57,14. You can see I've actually got the recurring decimal function on. Now, I don't think I put it in the presentation. So if you want to turn on your recurring decimal, press your setup button, choose a 5 for recurring, and then press 1 for on, and that will then make sure that when you have a recurring decimal function or a recurring decimal, it actually shows it to you as a recurring decimal with the bar on top. Now, For your next mark, all you have to do is type in the next student's mark and press equals, and there we go. Again, you'll see the recurring and the regular decimal. And then the next student's mark equals. So it's just mark equals, oopsie, that's going to be too high. Mark equals, and we are done. So a very nice shortcut for you if you haven't seen that before. What's nice is you can share this with all of the teachers as well. So exponents, just some nice rules. I know that we cover these rules in grade 8 and 9, but it's always good to repeat them. And the reason that I've shown this here is because you can also use this method to teach surd notation and the various surds in grade 11 that we talk about. So I'm actually going to jump to there. Okay, apparently I'm not going to jump to there. But just to show you quickly what I mean. So for example, when we talk about multiplying exponents with the same base, and the rule is then that we add the exponents. So we can show our students that if we did prime factorization, we can see that 3 plus 4 is 7. We can also put it in directly and show them that we get the same answer. So it's just a nice way to prove the rule to your students. Now I'm using second function and exp, which is pfact, to find the prime factor of any number. If you have a number that is a prime number and you press second function pfact, what you'll see is that the comma behind the number goes away, and that indicates that that is a prime number for you. Now, here's what I was talking about with regards to surds. Now we can use the same methodology here from the exponents that we did with the surd. So for example, when we multiply surds with the same root, we actually multiply what's inside the surd, right? So we could also write it as so, and that will give us the same solution as well. So it's just a nice way to demonstrate that these rules are in fact true as well. Now for grade 12, when we start talking about logs, you also need to be able simply to input the log. So they've taken out quite a bit of the log laws. It is in technical maths and AP maths. So what you do is say second function and your pi button. That will give you log with the base, where you can select your base. Okay, so what you then do is put your base in, press your right arrow key, type in your number, and then press equals, and you should get your answer. If you want a log with the base 10, you would press this big log button over here, and then put in your number straight away. So then you don't have to fill in your log base 10. Ln or Ln is a natural log, and so that is base E. So if I put in an E, which is over here, you can see that that's the answer there. Not that we use the natural log in matric, but it is good to explain it to them as it becomes quite useful in university when we talk about finances and biological growth patterns and all sorts of that sort of stuff. Okay, so number patterns, there are 3 different types of number patterns, and I want to jump through. So I've put the linear number pattern here through to, and the geometric pattern, but what I want to really talk about is the quadratic pattern. Okay, so there are 2 methods that you can use to solve for your quadratic formula. So the first method is obviously to use the formula, the a plus b plus c, the 3a plus b, and the 2a is equal to, and then your first term, first difference and second difference, or to use simultaneous equations. So the first method is great if your students are capable of learning a formula. Okay, and so this is really nice for those whose memories work where formulas are concerned. However, this is not given on the formula sheet. So as an alternative, you can also work backwards. And so that's what I want to show you here today. So for example, I've got the pattern here, it's 1, 3, 2, 3. So we can see we're adding 3. So how did we get to 2 when we added 3? We subtracted 1, right? And from what did we subtract -1 from to get to 1? We subtracted it from 2. So our C value is 2. That's the C value here. So it's quite a basic, intuitive way of doing the quadratic formula. And I must say, I grew up using the formula, but I feel like this way is if a student understands what a quadratic formula is, this is an easier way to find the pattern. So now we would just substitute in our 2 for C. And then what we would do is, this is term 1 and this is term 2 and term 3. So we would substitute in our 1 is our n and our value y is 1. And then again, our y value is 3 and our term position is 2. And we would substitute and then solve these simultaneously, which they should be capable of doing in grade 11. It's quite a straightforward 2 linear equations to solve. So here's all the working out that you can see here, and we can see that it gives us exactly the same answer as the previous solution that we had here. Now, there is another really nice shortcut that I want to show you, and this is particularly nice when you want to check your students' work quickly, or they want to check their work in the exam. So I'm just going to move this a little bit so that you can see both of my screens. Because I want to show you something very cool. So we're still talking quadratic formulas, but we're going to use our stats node and this number 2 here, which is a plus bx plus cx squared, which you can see is the same as your quadratic formula, except obviously the a and the c are switched around. So what we would do is we would type in all of our x's. Now, there's 2 ways to do this. You can just type in your position, which is 1, 2, 3, 4, and then go back up and type in all of your y's. I personally don't like using that method because I feel like it opens you up for a lot of errors. Whereas if we type it in as a coordinate pair, we have to make sure that position 1 is linked to the value of position 1. And I'll do this again in linear regression as well. So what will happen is, so you press your position, press your x, y in brackets button, and then press your term value and press equals, and the calculator automatically fills it in the table for you. Okay, so for me, it's firstly shorter, and secondly, it's much safer in terms of errors. You're much less likely to make an error if you're putting the coordinate in together. And if you skip one, or you put in a 5 and then you mismatch it, your whole thing is not going to give you a big error. So you can go back and check and make sure that everything is correct. Okay, so I filled in the first 4 terms and its value. Once I'm done, I'm going to press change, and change just takes me to my calculation screen. Okay, so I can change again to go back, or change back, or I can press, for example, on to clear the screen, but I cannot press on to go back to my data. So that's just the difference between change and on. Now we need to find the formula, so we press alpha and 8, and this time we're going to press 1 for regression value. And here you'll see it's given you your value of 2, and b is -2.5, and your c, or the coefficient of x squared, is 1.5. Now if I go look at what we found, I can see the coefficient is 1.5 of n squared, -2.5 for b, and my a value is 2, which we found there as well. So you can see it's quite a nice checking mechanism. What's also really nice about using the calculator for checking is that we can find terms. So for example, if I want to know what the value of the 5th term is, because I now have the equation, the calculator has calculated this equation, I can say, okay, I've got position 5 and I want to know what my term value is. So that's my y. So I would then say second function and my y hat button. And you can see that it gives me 27. So at position 5, my term value is 27. If, for example, we're told that our term value is 188, and we now want to know what our term position is, we can then say second function and open brackets. And you can see in orange above it, it says x to the y, x prime. And so that gives us two values, because we're talking about a quadratic formula or a parabola, which has two x-intercepts. So here, obviously, we would ignore the negative 10, and the fact that it's got a decimal also tells us that it's not a valid value of n. So the only solution here is 12. Again, this is really nice for checking your answers and making sure that you've got the right thing. However, I like to teach it to teachers, and it's your prerogative to share it with students. Okay, so let me show you some other cool stuff. So you got highest common factor, which is very easy. Let's do 60, and we're going to just say second function 2, and then we'll use 72, for example, say equals. We can see our highest common factor is 12. Now you can do this with as many numbers as you like. It's really up to you. Most questions are not going to ask more than 4. And I've actually done this in the stats mode. I should have done this at normal mode, but it doesn't matter. So you can see, again, doesn't matter where you do it, that you can do as many of these as you like on your screen. So until you run out of characters, essentially. Now we've also got the lowest common multiple. So if we use the same values, it's on second function 3, which gives you LCM. And we type in 72 and equals, and we've got an LCM of 360. And again, you can type in as many values as you like. You're not going to run out of, well, you could, but it would take a long time. And so it's a really nice and easy way to find your LCM or your LCD. So for grade 10, the LCM is quite useful in terms of finding your lowest common denominator when you start talking about algebraic fractions. Now, you can also find factor pairs, and I'll show you this. We're going to use our table mode here. So mode and then to table. And what you do is you just type in a number you would like factor pairs of. So say, for example, 48. Press the fraction button, press RCL twice to make an X, and then just press equals, 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 equals. And you can see anything divided by 0 is undefined or an asymptote. So your asymptote actually looks like an asymptote on the calculator. Then our factor pairs are 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6. So we can see 5 is not a factor because it has a remainder answer, so we would ignore it. 6 and 8, 7 is not a factor, 8 and 6. So we can see that the numbers have reversed. We found all of our factor pairs and we are now done. So how does this help you? Well, if we're talking about factorizing a trinomial, what it does is it allows you to find all the factor pairs of your C value. And so we can then do our rules. So when we look at this one here, so I won't do it on the calculator because 6 is quite basic and I chose it for that exact reason. So what we'd have is our X column and our answer column, okay? And the factors of 6 would be 1 and 6, 2 and 3, 3 and 2, 4 and something else, 5 and something else, and then you'd have 6 and 1. Okay, so when the sign at the back is a plus, it means my signs in the brackets are exactly the same. And I take my sign from in front of my B, so it's a plus here and a plus here. And then I add my two columns together to find my little term. So 1 plus 6 is 7. Well, what will it be for? 2 plus 3 is 5. Yes, it is. So I can just fill it in here. Again, you can do exactly the same thing, and you can see the solution is exactly the same, except the signs are different here. So my sign at the back is a plus, which means my signs in my brackets are the same. I still add my values together to get my little term, which is 5, which is still going to be 2 and 3. Now, for this one where the sign at the back is a negative, here we know that the signs are different, so we don't fill in the signs yet. What we do is we make one column minus and one column plus. So we're going to have -1 plus 6 gives me +5, not what I'm looking for. -2 plus 3 gives me +1, still not what I'm looking for. -3 plus 2 gives me -1. Yes, that is what I'm looking for. So I keep my signs. So I've got -3 and +2, and I've now factorized my equation. And this will work for those equations where your a value is equal to 1. Now, there are other methods for solving where your formula has an a value that is not 1. And we actually do have a full video on the YouTube channel where you can watch through all of the different techniques for factorizing that we've done. So take a look at that one. Now, what's really nice here as well is that we can use the calculator for the quadratic formula. So I want to share both my screens with you again. You can see both. And so what we've got is our expression, which is 3x squared minus 51x plus 17. I should have written equals 0, but anyway. And what we're going to do is we're going to save the a, b, and c values into our a, b, and c memory keys. Okay, so to do that, we write down first the number we are saving, then we press store and we save it into the memory key that we want to save it into. Now, for -51, we must remember to use the negative button and then type in 51. If you press minus, what will happen is it will try and subtract from the previous calculation. So that's why it's important to use the negative button. Store and B, and then we have C is 17. So we're going to say 17, store into C. Now, once that's done, it's pretty straightforward in terms of writing in the formula like it looks like. Okay, so what we would do is we've got negative, and then to make it B, we say alpha B. Plus or minus. Now, obviously, we can't do plus or minus in the calculator. That would be confusing. So we're just going to use plus for now. Square root. And then we've got B squared. So that's alpha and B. And then squared minus 4. We've got A, so alpha A, and then C, alpha C over 2 alpha A. Okay, so we've got all of that. And then all we say is equals, and we've got our first solution. To get to the second solution, instead of typing this entire equation or expression in, what we can do is just edit it. So instead of pressing the left arrow key 20 times to get to my plus sign, I'm just going to press second function left, and it will just take the cursor to the front of my expression. So if you want to edit something right in the beginning, use second function left to get to the front of the equation. And press equals, and there's our second solution. Now, what's really nice here is that you can store into A, B, and C again. So 3 store into A, B will make, and C will make. I hope it works. And then what you would do is you would simply go back and press your equals button on the expression again. And we can just go back and edit that instead of having to look for the other one and get our two solutions. So if you're doing a lot of these calculations, using the memory keys is quite helpful for your quadratic equation. Now, I'm doing extra maths with a student. Poor her. And no, I'm kidding. One of the things that she really struggles with is the factor theorem. So I wanted to share this technique with you simply because I feel like a lot of students don't quite understand what the factor remainder theorem really is. So, oh, I've done the wrong thing now. Here we go. Okay. Sorry, blonde moment. So here's my factor, or sorry, my expression or my formula, my cubic equation, right? So the factor remainder theorem says that when x minus c is equal to 0 is a factor, or x is equal to c is a factor, then if you substitute the value of c into your function of x, it should give you 0. If it doesn't give you 0, it's obviously not a factor. So how do we prove this on our calculator? So we're going to go and use table mode, right? And we're going to plug in this expression. So to make an x, we press RCL twice. The quick way is just to press your exponent button and press 3, and then press your right arrow key, minus 4, RCL button twice, squared, minus 17, RCL button twice, that's 60. So that's the same thing, right? And then we press equals. We're going to ignore function 2 for now, because that's, I don't want to muddy the waters here. And then, of course, leave your start and your step at 0 and 1. Now, the factor theorem tells us that we are looking for where our answer is 0. So if I scroll down my table, I can see that x is equal to 3. So in other words, my factor is x minus 3. If I scroll some more, I can see my next one is x is equal to 5, or x minus 5 is a factor, is equal to 0. And then if I continue scrolling, I can see that my values are just growing exponentially. So I'm missing one factor. So let's go back up the table. So what's really cool here is, even though we started at 0 and we specified to start at 0, it doesn't matter in which direction you go. Your calculator table is unlimited. So this brings a lot of other awesome applications to the table. And you can see here at x is equal to minus 4, our answer is 0. So in fact, our factors, I haven't written them down, silly you. Our factors for this giant equation would be x minus 3, x minus 5, and x plus 4. Now, generally speaking, the reason that I did, the reason that we have such beautiful answers is because I went and looked, created a polynomial with these as factors and worked backwards. Okay, so it's not necessarily that you're going to always get that, but a cubic equation will always have at least one real answer. So you can go and find it using your factor remainder theorem on calculator. Okay, so trigonometry, there's some really nice shortcuts here. So let me show you this one. You're going to go back home. Home just takes you back to normal mode from whichever other mode you are in. Okay, so we're going to say we have these keys here, D1, D2, D3. Okay, these are your shortcut keys. And basically, you can save any functions that are already on the calculator that require 2 or more button presses. Okay, so we can store into D1, and then you can choose to say second function sine. And what happens now is, instead of having to press second function sine, you can now just press D1 instead. So it's just a time saving mechanism, or a button saving mechanism, for lack of a better explanation. All it does is it saves functions that are already on the calculator for you. So it is not programmable, just as a heads up. It's just allows you to save a function. It does not allow you to save a. So for trigonometry, what's nice is you could save into D1 your arc sine, into D2 your arc cos, and into D3 your arc tan, and then that would then give you the degrees. So if you D for degrees, and then obviously these ones would give you your ratio. So very nice for grade 10 for reminding students, okay, when I'm looking for the size of my angle, I can use my D keys, but when I'm looking for the size of my ratio or the size of the length of my line, I'm using my original keys. There's also this really nice shortcut for Pythagoras, and we use it here in trigonometry. Just let me grab my pen here quickly. So say, for example, we have a Cartesian plane with the coordinate P. Sorry, my hypotenuse is so skewed. And the P coordinate is 12 and 5. So what we would then do is our X is 5, so we're going to type in X first. Our Y is 12. So we type that in second. quadrant, and we would just press second function and 8 for our theta. And that will give us 13 is the length of our hypotenuse, or our, I've lost the word, and theta is the angle that the x makes. So what we've essentially done is converted from rectangular coordinates to polar coordinates. Now I do have to specify some things here quickly. Because this is a shortcut to convert between rectangular and polar coordinates, you cannot put half of polar coordinates. In other words, you cannot put in the r and a y and expect to find your x. This is very much simply a checking mechanism on the calculator. You can't go back and look for all the other cool stuff. It's simply there to assist you to check that your answers are correct. So if, for example, you found x and you want to make sure that you are correct, you could substitute x and y in, and if it gives you the same r value that you have, then you know that your solution is correct. Now you can also teach the class diagram using the table mode on the calculator. Okay, so to do that, what you do is type in a sine graph. So I'm not going to do it on the calculator now because you can see my steps here, but I do want to show you my method. Okay, so between negative 180 and negative 90, we can see that my answers are negative. Between negative 90 and 0, I can see my answers are negative. So all I'm doing is filling in the signs. Once we've done filling in the signs, we can go look at the Cartesian plane and we can see, okay, sine is negative between negative 180 and negative 90. So sine is negative here. Sine is positive between 0 and 90. So I'm going to put a sign there. And sine is positive between 90 to 180. So sine is positive there. Now, if I filled in my cos and my tan graphs, what I would see is that cos is positive here and cos is positive in the last quadrant. If I filled in my tan graph, it would be positive in the first quadrant and positive in the third quadrant. And we can see that all of our graphs, all of them, positive here, and that only cos is positive here, sine is positive in the second, and tan is positive in the third. And we can see where the cast diagram comes from. So it's just a nice mechanism for showing them exactly why. And what's also really nice is it gives them an understanding of the fact that the graphs are repetitive, that you're going to keep seeing the same repeating values over and over again. If you just scan through and look at these, you can see here's negative 0.7071, here's another negative 0.71, positive 0.71, negative 0, negative 7, positive, and so on. So you can see that as we go through this table, that the graphs are actually just repetitive and repeating themselves again and again. And that's why we have the cast diagram. Now, I'm not going to go through all of the steps for solving a trigonometry equation here with you because you're all maths teachers. But I do want to show you a really nice shortcut. So I've done the steps here so that if you want to go back and follow along with my logic, you can see it. So what we do is we create a reference angle, okay? And again, we're using our cast diagram, okay? And we're saying that sine is positive here and here. So our first solution is just going to be our original answer and then obviously bring the 30 degrees across. And so our first general solution is this one here. Then we also have sine is positive when we have 180 minus our reference angle, so that's this solution here. And so our final general solution is this equation here. Now, if we are looking for a specific solution, okay, I'm going to pull up my calculator and I'm going to show you something really cool. Just want to pull up so that you can see both. There we go. Okay, so what we would then do is go back to table mode. I told you table mode is awesome, right? And we would fill in this first general solution. So in other words, we're not going to fill in x is equal to, we're just going to fill in this part here. So we're going to have negative 10.53 plus Now, obviously, we don't have a k on the calculator, so we're going to use x instead, times 360. And then in function 2, we're going to fill in the second one here. So we're going to have 130.53 plus, again, we're going to use x instead, times 360 degrees. Now, our question is asking us for solutions between 30 degrees and 200 degrees. So just skip these two. Well, just leave them as they are because we're substituting in k as -1, 0, 1, 2. So our x value is our k. Right, so let's start at -1. And we can see that our answers, solutions specifically in that region, are -370 and -229, which doesn't fall into the space where we're looking for on our graph. So we can ignore those solutions. Then we have, when we substitute k as 0, we have -10.53. So again, that doesn't fit with our restriction. And then we've got 130.53, which does. So that's one of our specific solutions. And then if we look at k is equal to 1, we can see that now the values are higher than 200 degrees. So we have found our specific solution. There is only one, and that is 130.53. But you can see that it makes it quite easy in terms of k substitution to simply use your table mode to input your general solution and find your specific solution. Any questions so far? Are we all good? Okay, fantastic. Remember, if you do have questions, just to pop them into the chat or the Q&A function as well. So I'm not going to go through too much of functions. What I do want to show you is that you can use functions to teach graphs. Okay, so what I've done is in function 1, I've put in an x squared, and in function 2, I've multiplied the x squared by 2, and then I've looked at the values, and I've plotted those values onto a Cartesian plane. Now, I've used GeoGebra for this because it's quite easy to take GeoGebra graphs and input them into the presentation. Wow. So you can see here that this is my original graph here, my parabola, and then at the top is my one that is multiplied by 2x squared. So the higher your value of a, the thinner your graph is going to be. Now, if we changed our a value to 1/2 instead and plotted those values, you can see again, this is my original graph of x squared, and here is my my graph where my a value is equal to 1/2. So the smaller a is, the wider your graph will be. Now we can do the same thing where we talk about shifting up and down, and you can see the shift remains the same throughout the graph. So it doesn't change the shape of the graph, it changes the position of the entire graph. And you can shift from left to right as well. And you can see again, the shape of your graph is exactly the same, it's just moved over to the left. Cool. Simple and compound interest. So I don't know if there's anyone new here today who hasn't seen this before, but it's pretty cool. So I'm going to actually just do both of them with you quickly at the same time. So what you'll do is in table mode function 1, we'll put a simple interest formula. So let's say we have 1,000 Rand, open brackets, 1 plus, and let's say our interest rate is 12% per annum. But we're doing simple interest, so it's just 12%. And then here we would multiply by our n values. So here I'm going to put in an x and simply close my brackets. In function 2, just to save some time here, I'm going to put in my compound interest formula. So I'm going to use exactly the same values, 12% per year, okay? And this time it's compounded yearly. So here again, to make it comparable, I'm going to put in an x as my n value. So skip. And what you'll see now is initially we both had 1,000 Rand in both accounts. After 1 year, both accounts have earned 120 Rand, right? After 2 years, though, your simple interest has still earned 120 Rand. And you can see if you scroll through the table that it continues to earn 10% of 1,000 Rand, or sorry, 12% of 1,000 Rand, which is 120 Rand, and so on. But if we look at our compound interest, we can see that we're earning 12% of the previous year's amount and not 12% of the initial value. So you can see that your compound interest is growing at a much faster rate than your simple interest is. Okay, so it's a very nice way to demonstrate the concepts of simple and compound interest with your students. We can also talk through an annuity, and what's really cool here is I'm going to share both screens with you. So here's my present value annuity, and what I'm going to do is in function 1, I'm going to type in an annuity where I don't know how much I'm going to pay per month. Okay, so I'm going to make that an X, my monthly repayments. The rest I'm going to fill in as 1 minus 1 plus, let's say you're buying a car. So you have a 10% per annum compounded monthly, which is that times 12. And then we're going to borrow it over 5 years and pay it back monthly. So that's that. And then it's all over the same interest rate, which is like so. Okay, so once you've got your formula, we'll clear function 2 so that we don't cause confusion, and equals. Now, I haven't adjusted my steps yet, but I do want to talk through this first. Okay, so what we've got here is how much I'm willing to pay per month over 5 years. And in my answer column, I've got how much I can borrow now if I'm willing to pay back X per month over 5 years. Okay, so if I am willing to pay back 5 Rand a month for 5 years, I can borrow at this moment 235 Rand. Now that's not quite a realistic thing, right? And I'd have to scroll quite far down my table before this started to become a relevant example. So what I'm going to do is leave my function as it is. And in my step, I'm going to change it to steps of 100. Now, you can see if I'm willing to pay back 500 Rand a month, I can borrow 23,532 Rand over 5 years at 10% per annum compounded monthly. If I'm willing to pay back 1,100 Rand, I can borrow 51,000. If I'm willing to pay back 2,000 Rand, I can now borrow 94,000. Now you can also reverse this. So let's say, for example, I want to buy a car, which is 150,000 Rand. So how much are my repayments? I can go look and I can see that 150,600 Rand will cost me 3,200 Rand a month. So it works in both ways. What's really nice here, again, also is that you can adjust your formula. So for example, let's say I get an interest rate of 11%, and I pay it back over 6 years. So all in all, it's just going to be much more expensive. 11%. Okay. And now if I go look and I want to buy a car for 150,000, I can just scroll through the table. So we find approximately 150. So there we go. So we can see that our repayments will be about 2,850 Rand or thereabouts. Now I can make this more accurate by changing where I start. So I could say 2,800 and make my step 10 instead. And now we can get a much better idea. So it'll cost me 2,860 Rand a month to borrow 150,000. So it's a really nice way to talk through present value annuities with your learners and help them explore and understand what affordability actually is, what they can put into their budget, and so on. We're still good. No other questions. Okay, fantastic. So there were a lot of requests for probability and for statistics. So I just want to go through this slide because often we get mixed up with independent and dependent events. So an independent event is an event that has no effect on any other event. So for example, if you rolled a dice, you picked up the dice and you rolled it again, rolling the dice for the first time has no effect on rolling the dice for the second time. However, if we talk about dependent events, then it means that your next event is dependent on your current event. So for example, with lottery balls, if you pull out a 55, you cannot pull out another 55. So you've actually made your sample space smaller. If we think about a bag of marbles, which seems to be a typical example, if you take out a red marble, your sample of red marbles now gets smaller. If you put the red marble back in, it then becomes an independent event. So that's the difference between it. Obviously, this has an effect on your formulas, and students should pay attention to that as well. Now, permutations and combinations, in terms of the fundamental counting principle, cause drama. So I do want to talk through this as well. So a combination is simply when you are throwing everything into a bag. So it's about volunteers. So if you have a class of 20 and 3 students volunteer to help you carry your books to your car, that would be a combination because there's no position for them to take. Okay. Whereas a permutation is when 3 students out of your 20 win first, second, and third place. Then you have lots of different ways of putting these students together in a group or into position of first, second, and third. So you can do combinations and permutations on the calculator. And a good way to remember which way is which is that a permutation will give you a lot more answers. So if we say, for example, we said we had 20 students and 3 volunteered, then we have a combination, right? So it's a second function and 5 to make your C for combination, and then 3 volunteers. We have 1,140 different ways that the 3 volunteers can come from your students. However, with the permutation, we have 20 students, and now they need to go into a position of first, second, and third. Right, so we still have 3 positions available, and you'll see here that your combination or the amount of different ways that a student can, or 3 students out of your 20 can be first, second, and third is 6,840. So you can see combinations are much less than permutations with the same number of options. Then let's talk through statistics. Okay, so I'm going to go back here and just share both screens with you. I'm actually, I'm just going to make up my own data here. So you can go back and look through the example later and see that it makes sense to you. So let's do SD, which stands for single data. So Mary's maths marks are there are so many cars today, so many petrol, etc., etc. Okay, I'm just going to type in random values. Okay. Once we're happy with our values, we can then again press our change value. Now, I put in a mistake on purpose. I made the 16, and I should have actually made it 61. Okay, so to change this around or to change the value, you highlight it using your arrow keys, okay, and your black square that goes around the number. Type in your new value and simply press equals, and you'll see it will just overwrite it immediately for you. Then we press change once we are happy with all of our data. Now we press alpha and 8, and we choose 0 for statistics values. And we can see we've got 9 observations. Our average is 64,4. Our standard deviation, remember we use the sigma x and not sx because the formulas are different. Okay. And then the sum of x and your 5-number summary is all available here for you as well. So it's very, very easy to do statistics on the calculator. Now we can also do linear regression with the calculator, so I don't want to use this example here. And so we'll go to mode and 1 for stats, and this time we're going to choose 1, which is our linear or our line a plus bx. And again, like we did with the quadratic formula for the patterns, we're going to do the same way of inputting data here. So we'd have 3, x comma y and 7 and equals, and then 4 and 11, 5 and 15, 6 and that's your x and 19, and 7 and 23, 8 and 27, and 9 and 31. Again, once you're happy with your information, you've made sure that it's all correct, you can press change or on. Either one is fine. Now again, if you press alpha 8 and you choose 0 for statistics values, it will give you your number of observations, your average for x, your standard deviation, the sum, minimum and maximum, and then it will give you the same values for y. So it doesn't give you the full number summary here, simply because for linear regression, you don't normally require that as well. Okay. Then you can also find your line or your linear regression line. So that's alpha and 8. And now you would just press 1 for regression line. And you can see your y-intercept is -5. Your b value or your gradient is 4. And r is 1, which means it's a perfect positive correlation for the dot. Okay. And then, of course, your correlation square is 1 as well. Awesome. So thank you so much for joining us today. If you have joined us on YouTube, please like and subscribe so that you can watch more videos. And again, if you have any questions, please pop them into the comments function down below. Cheers for now.